even though they just give you a short paragraph or a couple sentences, draw out whatever they're giving you. Okay, so this one is almost identical to example 1. This would be where I would like you to pause it, try it on your own, and then come right back and I'll go through this one a little bit more quickly. All right, hopefully you gave this one a shot. Now, I noticed already when I started reading it that still an angle in standard position that passes through the point 8, -6, meaning they gave me my x comma y for that point. So starting at the origin, when I go to draw this out, I knew I was going to walk right 8 and then down, so negatively 6. And when I do that, I then have my right angle and I can go ahead and draw in that third side to create my right triangle. And so do me a quick favor, see if you can just tell me without doing any work off the top of your head what that length would be. Now don't forget, it would have to be bigger than 8 because it is our hypotenuse, and then that has to be the longest side, because remember we said that the angle sum of a triangle is 180, and since this is 90, these two other angles have to add up to be 90, which we also call complementary. A lot of overlapping vocab here. So can you tell me, just by looking at that, what that length is? And if anybody was able to say 10, very, very good. This was a 3, 4, 5 in disguise, all doubled. So that similar triangle ratio that we talked about last section. So because I was able to skip my Pythagorean theorem of having to take -6 squared plus 8 squared and figure out what my r would be, I can actually just start finding what each and every one for this angle theta that we built would be for my big 3. And again, just the big 3, because once I know those, then I can just flip them, do the reciprocal for their reciprocal functions. So in this case, we have to find what the sine is, and remember sine is what? Hopefully you said y over r. So since we already know our y is -6, we had to find our r was that. The only thing they're going to want you to do on my math lab and of course in my class, simplify. So a little bit of extra work, but dividing top and bottom by 2, taking half of those, really simple. -3/5. And I'm going to simplify before I even flip it because I don't want to have to do that twice. So now I got -5/3 for cosecant. Now, the next one we would have to do would be cosine, which remember what that was? Cosine is always the what over what? And hopefully you said x over r. And this time, therefore, I'm going to use x, which is 8, r, which is 10, which we also know is 4/5. Notice you're getting those original ones that we talked about being the 3, 4, 5 in the end. Because they're all just twice as big, we can reduce it down and get it to a simpler form. And if that is 4/5, then we know this is 5/4. Okay, and then moving on, the last one would be what is called tangent. And if we're dealing with tangent, remember we should know that that is the what over the what. And that would be y over x. And in this case, that would give us a final answer of our y value is -6, our x value is 8, so -3/4, which, do the reciprocal, that's -4/3. And there are the 6 trig functions solved for the point 8, -6. Okay. Moving on to example 3, they want us to do something similar, but a little different look here. This time, they want us to find the 6 trig function values of some angle in standard position, meaning at the origin, rotated. But this time, they're going to say that the terminal side, where we end, is going to be defined by this equation here, where x is less than or equal to 0. Now, hopefully you know what that equation looks like. Definitely going to need a drawing for this one, because when we go and work with this, we're going to have to know that this is a linear function. So in order to get this in its proper form, I will add the 2y over. So on one side I have 2y, and on the other side I have just 3x. And then if I divide that by 2, I get my 1y is equal to 3/2 x plus 0, if you will. And that's now in my y equals mx plus b slope-intercept form, which allows me to start at the origin for my y-intercept, and then from there go up 1, 2, 3 tick marks, and right 2 tick marks to get to this point here. And because I know that that is what this line looks like, I can draw my line through those points. Now don't forget, you also could have gone -3, -2, and that's still positive 3/2. So you could have gone down 1, 2, 3, and left 1, 2. And notice I'm still on that same line. Now the only reason I did that was because they told us they only wanted x values that were less than or equal to 0, which means we're actually going to throw out this whole side of our line. They only want the x values that are less than or equal to 0. And if you notice, that is what we needed, because remember what we've been doing is drawing what every single time so far? That's a triangle. And not any old triangle, but a right triangle. And so from this, I would have had a right triangle here that I could have drawn for my angle theta, or here. And so that's why they had to throw this little caveat on the end and tell us only take half of that line from the origin. And in this case, they wanted the less than left side. So I will then drop this straight down, and I know that each of those lengths for my right triangle would have been a -2 and a -3 to get to that point, or that slope that we originally said of 3/2. Okay, so with this, is that a Pythagorean triple that we could use to find this side here? Was there a 2, 3 something? And hopefully you said no, unfortunately. So we'll have to take the -2 squared plus the -3 squared and set it equal to our r squared to find that. And so we know that the r squared is going to be equal to, this would be 4 positive, plus this would be 9 positive, which is equal to 13. Now don't forget, that's our r squared. We wanted just r by itself, so we'd have to take the square root to get rid of that. And remember, there's no negative radii, so we would only be looking at the positive root 13. So now that we have our x, which is -2, our y, which is -3, and our r, which is the square root of 13, you should now be able to find every one of our trig functions. So go ahead and pause it real quick and see if you could find those, and then I'll write them out for you to make sure you got the right answers. All right. Hopefully you were able to get the right answers, and hopefully you lined up the sine with the cosecant, the cosine with the secant, and the tangent with the cotangent, so that you have the reciprocal functions, because then that will allow you to just find the big three. sine, cosine, and tangent. So remember, sine is always the y over the r. Now, in the last one, I simplified and then I wrote in what cosecant is. You may look at this and be like, well, there's nothing to simplify because we have a root on the bottom, and you're absolutely right. But remember, we don't like to divide by things we don't really know. Do you know what the square root of 13 is? Well, then that's why we what is called rationalize the denominator. We try to get rid of it by multiplying by that fancy 1 I told you guys about in a previous video. And it's pretty easy to figure out what this one is compared to the ones that we were doing before, because all you need in under a square root is something squared. So you multiply by itself, and now you have something squared under there, that 13. So that 13 gets to come out, and we do what it says on top and multiply. And that's all we would have. Now, unlike the previous example, it was better to simplify and then do the reciprocal to find cosecant. But in this case, I don't want to flip this, because then the root would go right back down on bottom and I'd have a similar case to do over here. So I'm going to take what it originally was here, and I'm just going to flip that over here. So I'm still going to be negative, right? But now I'm going to have the square root of 13 over the 3. And that would be my final answer for that one. So yes, these were a little bit more daunting. I hope you did take on the challenge, but when there is a root on bottom, they are going to want you to rationalize and get rid of it by multiplying by that fancy 1. So cosine, remember, is always the x over the r. So similar case, we're going to have to multiply by that square root of 13 to get this. But in order to get secant, I'm actually going to use this to flip. So I'll actually put root 13 over the negative 2. And whether you put the negative on top, bottom, or out in front, all the same. All right, and then lastly, cotangent and tangent. So I'll start with tangent. Remember, tangent is the y over the x, which the only simplifying we can do there is taking a negative divided by a negative and making them positive. So we get 3/2. And that makes cotangent really easy, just flipping it. So notice that some of these are positive, some of them are negative. We'll talk about where and why that happens. Some of you guys may already know this. All students take calculus, right? So this will help us to remember which are positive in quadrant 1, all of them, because x and y are both positive. Okay, but in quadrant 2, only sine is positive. And of course, if sine is, then so is cosecant. This only talks and pertains to the big 3, because here it'd be a negative x and a positive y. And since sine is always the y over the r, since y is positive in both of these, that's why everything in quadrants 1 and 2 are positive for the y value, and therefore so is sine. Okay, now tangent, this would be negative for quadrant 3. Y over x, just like we had here, that's why tangent is positive only in that quadrant. And of course, cotangent. And then lastly, you just need to know this is only pertaining to the big 3. So this C does not talk about cosecant or cotangent. It's only representing these big 3. We'll deal with the reciprocal functions based off of those. So the C stands for cosine. And because this is positive, comma, negative in quadrant 4, that's why cosine is positive everything to the right, because it is the x value over the r, which is always positive. Okay, so that can also help you to find some of these values when working through it. So here's a couple more looks at what we can do or be asked to do when finding all 6 trig values. Now I'm just going to find the big 3 and let you guys do the reciprocal from here on out. But if they ask you for all 6, remember, you really only need sine, cosine, and tangent, and then make sure you know which ones pair with what for the reciprocals. Okay, but this time they're giving us 180 degrees. So of course, I want to draw that. And if I'm drawing that, I'm then dealing with what is called a straight angle. So 180 degrees would take me from here all the way to here, and that would be my angle. Again, starting at the origin. So when I go to draw this, there's no real way to draw it nicely, right? I mean, is this the theta? Is that going to help me? No, because what have we been drawing for every one of the first three examples? Remember the class name, Trig. We've been drawing triangles. So even though this technically is my angle theta, when I land on one of my four quadrants, remember we called it a quadrantal angle, we already know those values. And if you had to pick any radius you wanted, what's the easiest one that you would pick? Hopefully you got my hint, my innuendo there. It would be a radius of 1. And therefore, I already know this point here. From here, how would I get there? I would go left 1 and up and down none. And therefore, we already know our x is -1, our y is 0, and our r is 1. And if you know those three values, you should be able to find all 6 trig functions. Now, don't forget, though, there is a 0 involved. So when you go to find some of these, will be undefined. They do not exist because we cannot divide by 0. So just to do one of these, I'll do the whole thing out, and then I'll let you guys figure it out from the rest. But sine, remember, is always the y over the r. So in this case, that would be a 0 over 1, which gives me a 0. Now, even though this is my simplified answer, in order to do the reciprocal, I need a ratio, a fraction. So I'm actually going to be looking at this to flip over here. But if I do flip that, that would give me a 1 over 0, which hopefully you know is also not 0. We cannot divide by 0, right? So if you have a number over 0, that says no. When you have a 0 over n, that can equal 0. It's on, all right? So be careful. Make sure you're very, very aware of the 0 on bottom. Can't do it. We say it is what is called undefined. All right. So in this case, that's what we would have to put as our answer. Or some people will put D in E. It does not exist, but undefined is the proper solution. Okay. Cosine, remember that is always the x over the r, which in this case would be that. -1 over 1, which is -1. If you flip that, you still get -1. Right? And then the last one there would be tangent, which is the y over x. So y over x, which in this one would be a 0. But when you flip that, you get -1 over 0, which is undefined again. So we had 2 trig function values for that theta angle of 180 degrees that were undefined. That's what's nice about quadrantal angles. You didn't need to draw an entire triangle. And when you start just seeing these, you'll know the x, the y, and the r. You'll have all that memorized. You'll be able to knock those out real quick. So part B, I wanted to just give you another type of way of asking you for a quadrantal angle. And that's through a point. But if one of the values is 0, whether it's the x or the y, you know you're going to be on one of your 4 quadrants. So if you wanted to draw this out, again, that's fine. Just know that you would be down here 1, 2, 3, 4, 5. Which means we know our x, they gave it to us. We know our y, they gave it to us. But what would be our r to get here? And hopefully you did not say -5, but 5. So now that we have our x, our y, and our r, we can find any of those. And remember, when the x's are 0s, we are going to have some issues. And that's going to be with anyone that has the x involved. Its reciprocal part. Because then the x would move to the bottom. So that means cosines reciprocal, which would be secant. Tangent, which is y over x. Cotangent, it's reciprocal. All right, so give those a try. And just in case you wanted a nice map of what all of these are, I mapped out every single quadrantal angle for you. 0, 90, 180, 270, and 360 for every one of our trig functions and their reciprocal. Notice one really, really nice thing about this graph. Sine and cosine. They don't have any of the undefines like all the other ones do, which have either 2 or 3 different places where they're undefined. That's all I got for you. I hope you guys learned a lot from this one. If you need to watch this one back, again, it's very, very important. Don't forget your SOHCAHTOA that you may have remembered from geometry, quadrantal angles, all those new things. Pythagorean theorem you should be used to. The distance formula doesn't come up a whole lot, but again, you can see it can be useful. Very, very important to memorize sine, cosine, and tangent and what their values are according to that, what we call unit circle. So keep plugging away, start memorizing these as quickly as you can because we will keep adding on more things to work with those. It's been a pleasure. I'll see you guys all next time.